Welcome to Day 10 of my Inventor.io 30 Days Lost in Space adventure. Day 10 is more of a freestyle day, just like we had on Day 5. So one of the suggestions was to try and make a nightlight of sorts. So what I did was, I did a couple of things. I've got a whole bunch of stuff connected to my breadboard right now. One of them being this potentiometer. Another one being this push button. This is just a push button that I'm going to be using on a CNC machine, actually. I got these, and I figured I would just test it out and see if it worked. So I just set up the button to just trigger the red LED. When you press it, it goes on. When you release it, it goes off. Still trying to figure out C language to make that toggle. So when I press the button, it latches in the on position, and then when I press the button again, it unlatches. I'm going to have to do some digging on that one. The multicolor LED, what I have set up right now is I have it set to where if I turn the potentiometer slightly, I can then vary the amount of light coming out of the LED light with the potentiometer. If the potentiometer is in the 0 position or the off position, the light sensor then becomes active. And then depending on the amount of light going to the sensor, the light actually gets brighter as the room gets darker. So if I hit the light switch, you'll see that the light gets really bright. The LED light is actually its own worst enemy for the photosensor, because the photosensor picks up the light from the LED, and then it starts to make the LED flutter because it sees light coming in. And if I put my thumb over the sensor, you could see that it gets really bright. Now, I did that in a sort of strange way. I don't know if it's the right way to do it. I'm sure there is a different and better way to do it. But when I go to the computer view, I'll be able to break it down and explain to you what I've got going on. Again, it's a little unorthodox only because I'm not professionally trained in computer code. So I'm just kind of poking and prodding and seeing what works. As a side note, if I take the flashlight from my phone and I shine it onto the photosensor, you can see that the light goes completely off. So once it reaches its maximum light sensitivity value, it will turn off the LED. Also, if I just change a little bit of my code, you'll see that I can reverse the direction in which the LED gets brighter. So with a quick change in my code, I went from clockwise direction making the light brighter to clockwise direction making the light darker. And you can see that right here. And if I put it back the way it was, I turn it, and it's back to normal values. So let's go to the computer view, and I could show you what I have here. It's pretty interesting to see it kind of come into fruition the way I'm doing it. Okay, so as you can see on the left-hand side, I've got my declarations on the very top. I've got my int red, int green, int blue. And I just assign those to pin numbers. I'll assign my sensor, the photoresistor, to A0. I'll assign my potentiometer to A1. And for what I was doing with the button, I'll declare those. And that latch red was something that I was playing with, trying to set an internal variable within an if statement, but that didn't seem to do the trick. I figured the if inside of the loop would double back and find that value and then enable and disable accordingly, but it didn't quite pan out the way I expected. But I'm going to keep working at that. Once I declared all of my variables, I then created a void function called RGB underscore color. And then from there I pass in 3 arguments of red val, green val, blue val, just like we had in the lesson for the multicolor LED. And then after that, I did it this way. It doesn't have to be this way. I just wanted to play around with different functions. So I created a function called int sensor value. And inside of there, I put integer sensor val equals analog read sensor divided by 4. And what this does, because I noticed that when I was using the potentiometer, at least, when I would use the potentiometer will output a value from 0 to 1023. So every time it would overrun 255, it would kind of go back to 0 and then count back up. So as you would turn the potentiometer, it would get brighter, and then it would kind of sawtooth. It would go down to dim again, get brighter, sawtooth down, back to 0, get brighter, and it would do that 4 times. So what I did was I divided it by 4 to get a resulting value of 255. 255 seems to be the happy PWM value that the multicolor LED will go from lowest brightness to highest brightness within that range. And you'll notice that I put a negative next to the analog read, and that's the important trick to getting the light to increase as the LED to increase as the light level increases, is with this negative value. And then that function will return sensor val as the value in my loop. I also have another function called pot value. Same thing. And this is just to analog read the potentiometer value divided by 4. And then there we return pot val. Kind of got them backwards because I skipped ahead a little bit. But this will work the same way as the previous rendition of it. Inside of my setup, I'm just going to apply my pin modes. And I'll start my serial begin, which gives me access to not only the PWM signals, but also allows me to use the serial monitors down inside the loop. So the setup section doesn't have anything new or special. It's just the same pin assignments and then the serial.begin. Inside of my loop, I just have a variable up here of my max value. So I create an integer, max val equals 255, totally optional. And then here, this first section is the push button section for the red LED. And then down here is the section for the photoresistor and the potentiometer. And then down here I just had a bunch of print statements just to monitor what was going on with the sensor value and the pot value, things like that. As a side note, if you want to read digital and analog signals inside of your serial prints, you could do a serial print line, and then inside of the parentheses you could do an analog read or a digital read and see what the current pin values are. So if I did an analog or digital read on one of the pins up here and output it to the monitor, if it were digital, I would see a 0 or a 1. And the analog signals, they just show me the raw data from the RGB color assignment, red, green, blue, with these values getting passed into them via the void function up here. So for the push button, I'm just doing an if digital read button is equal to 1. And remember, it doesn't have to be 1, it could be high, it could be true. And then from there we will do a digital write red number 2 to high. Underneath that we'll do an else digital write red 2 is low, and that will just guarantee that the light turns off when the button is released. In this section here, I'm doing something a little bit different because I'm calling the functions as my comparators. So I'm just doing an if pot underscore value open close parentheses is equal to 0 and sensor value open close parentheses is less than or equal to negative, and then just for housekeeping I did parenthesis max val minus 15. I didn't need the parentheses. What this will do is it will just check to see if the pot value is 0, and if the light value, like we saw before, when the pot was off and I put the light onto the photoresistor, the light turned off, or the LED turned off. I used the digital write to guarantee that it was completely off, but I could have just done an RGB underscore color 000. So just because you are writing values in analog, you still have the option to force them digital. So that was another thing that I found out while I was doing this. If that condition is not met, we're going to check and see if pot value is equal to 0. And if pot value is equal to 0, RGB color will base its values off of sensor value. Again, the function that's up here. It's going to jump up here. It's going to check this function, and it'll return the values to my red, my green, and my blue. And all that's doing is just creating a white light. So I could make this really anything. I could put sensor value divided by 2, sensor value divided by 3, and sensor value divided by 4. And see what kind of funky color I get there. If that condition isn't met, we can do another else if, and we'll say if pot underscore value is greater than or equal to 1, which means if the pot has been turned slightly, and pot value is less than or equal to max value, which is the 255. We'll do an RGB color pot underscore value, and again using the functions we just create another white light. For my own sanity, I'll compile it, I'll upload. Went through no problem this time, didn't have any semicolon issues or anything. The potentiometer is working to where the clockwise direction makes it brighter, counterclockwise makes it darker. Once it's in the darkest or zero state, the photosensor kicks in, and then the light gets brighter as the room gets darker. Now remember, I changed it pretty much on the fly, so the potentiometer reversed the brightness direction. And what I did there was I just put negative signs next to each of the pot values in this conditional, so that when I turn the potentiometer, it changed the direction in which the values were written. And that was all I had to do, was just put these little negatives next to pot value. So that's an interesting little trick that I picked up doing this freestyle type lesson. Again, I'm sure there's different ways to do it. I didn't have to create functions. I could have just initialized these as variables inside of here, but I wanted the practice of creating functions and then passing them through. So I'm sure there's ways that I could have done this to where I could pass values into here, like this pot val. I couldn't figure out how to get that to work. I'm sure it's something on my end, because we were able to get the RGB one to work no problem. So I'm going to have to play around and see what I can do to get these returns to work the way that I think that they should work. Pretty interesting that all we had to do was really just make the read value a negative to get the sensor to work in the opposite direction. Not quite sure how that changes the compiled code, but it did work, so I was pretty happy with the result. So that concludes day 10. I did learn a lot as far as being able to play with these functions a little bit more, pass these values down, utilize the function calls instead of keying in values or using variables inside of here. I jumped out to functions and was able to keep everything kind of modular. So that was interesting. I'm happy with the results of that. But I'm going to keep playing around with this and see what I could do to clean the code up a little bit more and move on to day 11, where I have to disassemble my board because now they're introducing the 4x4 numeric keypad and ribbon cable. So I'm excited to get into that tomorrow. It's going to cover how to set up two-dimensional arrays. And arrays are something that have been kind of a thorn in my side ever since I started trying to learn C. So hopefully it kind of demystifies it a little bit, because arrays are very important with C language, and again, that's what Arduinos are kind of based on, C and C++. So I'm excited to get into day 11, but in the meantime, I want to get this video edited and uploaded for you guys. Thank you for watching. Thank you for your continued support. Please be sure to like and subscribe. My channel is fairly new. I do have a lot of new faces, a lot of new subscribers. Actually, since December of this past year, my channel has grown 560 users at this point. So I'm very happy with the amount of people that have been enjoying my content, and I really hope that the content that I'm putting up is something that you all enjoy. It's something that I have found a passion in, and I hope to continue that passion in the form of these Arduino lessons, Linux CNC stuff, CNC machine builds, probably going to get into G-code programming eventually, because that's kind of what I do, and hopefully build on things from there. I would like to build more machines and finish the machines that I currently have. So in between these Arduino tutorials, I'm hoping to get back onto my mini mill, and that will also be documented and put into the mini mill playlist. I don't know where I'm going with this, but I just wanted to kind of wrap with you guys for a little bit and just let you know what the future of the channel entails. And if you enjoy the direction that it's going, please let me know. If you're not happy with the direction that it's going, please let me know. Again, I do plan on getting back into the Linux CNC stuff, and that's going to be one of the main focuses of the channel, but this is kind of a pet project for me. I've wanted to learn C for the better part of 24 years, so that's kind of where my attention deficit veered off to for the time being. But don't worry, because the Linux CNC stuff is a vast ocean of knowledge and information, and hopefully I can learn more about that and work to pass that along to you guys. So again, thank you for watching. Please be sure to like and subscribe. Share the videos on your social channels if you are inclined to do so. Check out the affiliate links for the 30-day Lost in Space kit from Inventor Corp. If you'd like to support the channel, please check out my Patreon account. If you're interested in Linux CNC or CNC machine tool building, check out my other playlists. I have Linux CNC bare bones tutorials, PLC tutorials, hardware abstraction layer tutorials, and just general shop stuff. So thank you for watching, and we will see you soon.